Kathy and Jeff back again. Today we're going to talk about waves.
I got your memo about the topic, and so I grabbed my surfboard. Where's our field trip? California? Hawaii?
Jeff, I think you missed a line in the memo. We're talking about waves in terms of communication today, like radio waves or telephones or even TV. I'm sorry to disappoint you, but no surfing today, unless, of course, you decide to surf the web.
I should have figured a trip to the big waves was too good to be true. So this makes me think about a story I used with some students last year. Kwame's Sound.
Oh yes, that's an engineering is elementary storybook. How does that relate to waves?
Well, in the story, Kwame's dad is an acoustical engineer working with a research biologist who uses sound to track the movements of elephants in Ghana.
Yeah.
Kwame gets an idea that he could use sound waves to communicate with his cousin in another village. So he goes about designing a drum and a code for communication.
Well, that's exactly what we're talking about today. How does information, whether it's sound or light, pictures or words, get transmitted from place to place?
For example, in radio, the music or people talking is converted from sound to electronic signals. The electronic signals are converted into a pattern of waves that transmit from the radio station. The radio in your home picks up the waves and converts the coded information back into electronic signals, which travels to the speakers in the radio and is converted back into sound that we recognize as music or speech.
Television is similar to radio, except that the electromagnetic waves carry signals or codes for pictures as well as sound. We now have communication satellites that help transmit information for satellite radio and TV. Satellites orbiting the Earth receive radio, television, and telephone signals and transmit them around the world. They have the capability to receive, decode, and then encode and transmit information.
So let's look at a model for how waves carry information. I have a rope that will represent the wave. If Kathy holds one end of the rope and sends the signal, she's the transmitter. I'll hold the other end of the rope, I'm the receiver.
Okay. If I have a continuous flow of the rope or wave, this would be an analog signal, something like this. It just continues in one long stream wave. An analog signal is used in certain analog electronic devices, or even a human voice traveling through air could be an example of an analog signal. So if the flow of the rope or wave is broken up into pulses, this would be a digital signal. So an example of this would be a pulse and a pause, a pulse and a pause. Of course, that happens very, very quickly. Digital signals are used in computers, CDs, DVDs, and other electronic devices. To make a correlation to the system of zeros and ones used in computers, let's say the simplest digital signal sends one pulse, and that represents a 1 in the computer. And 2 quick pulses would correspond to a 0. In a computer, 1 means the switch is on, and 0 means the switch is off. By sending the on or off signal very quickly, the computer can interpret the code being sent by the transmitter. The on or off patterns are codes for the computer and can be translated back into information.
After using the resources on the Moodle to teach the students about waves, amplitude, frequency, digital, analog, and electromagnetic waves, and how TV and radio work, let them do a little research or learn to read how a computer transmits and receives information. Don't bog down too deep on this. A general understanding of the zeros and ones and what the binary system is all about will be deep enough. We want students to just have a basic awareness of how the computer works.
In any case, all of these communication systems do the same thing. They encode information, transmit the information as waves, receive the information, and then decode the information. So you'll find this as the common series of events. We've seen that in a lot of the MCAS open response questions.
Well, since we can't use my surfboard, let's look for something else that could be really fun and does model the process that Kathy just described. Let's try using Morse code.
So Morse code is a way of communicating with a series of sounds or flashes of light. Just like the computer uses that binary system with 0 or 1, in Morse code, the sound is either a short burst, represented as a dot, or a long burst, represented as a dash.
So I'm going to send a Morse code message, but I could do the same thing with a flashlight and send a light message. Either way, the code is being transmitted by a wave, either sound or light, to the receiver, which is Kathy's eye or ear. She'll be using a Morse code translation chart to interpret my signal. We've uploaded some Morse code information to the Moodle site, so check that out. All right, here goes.
So why don't you just give our viewers a sense of what a dot is going to sound like and what a dash is going to sound
Okay,
like.
so a dot is quick, a dash is longer. Okay, you ready?
I think so.
All right, so it's dot, dot, dot.
When I look at my chart, I see dot, dot, dot is the letter S.
Pause, 1, 2, 3, 4, 5. Dash, dot, dash, dot.
My chart gives me that as a C.
Pause,
Okay,
1,
I got
2,
this, Jeff.
3.
I got this.
Then it goes. Pause, 1, 2, 3.
Could you do that last one again?
Okay.
Tell
It
me
was-
what you've got.
I've got a dash,
Yep.
dot, dash, dot,
Okay, got it.
and just a dot.
Okay, Jeff, I think I got your message.
Science matters. Yes, it does. So let's take a look at the resources on the Moodle site and make sure to have fun with your students as they learn about this very important topic.
Let's take a look at Unit 5, Waves and Information Technology Transfer. The duration for this unit is 4 weeks. The big ideas are that energy travels in waves, sound, heat, and light energy can travel in waves, waves have properties including amplitude and frequency, and different types of waves move differently through various materials or various medium. For example, ocean waves are moving through water. We can talk about earthquake waves moving through layers of the earth. We could talk about sound waves moving through a solid, a liquid, or an air. If we take a look at our curriculum map, you'll see that this unit is heavy in science practices. We're going to construct and label diagrams, interpret and analyze those diagrams, make models, communicate results. We're going to construct and support an evidence-based claim. Our standards, we take a look at this content standard where we use diagrams of a simple wave to explain that the wave has a repeating pattern with amplitude, frequency, and wavelength. We're going to talk about diagrams and other models to show that both light rays and mechanical waves are reflected, absorbed, or transmitted through various materials. And lastly, we're going to look at that communication and information transfer standard. We're going to present qualitative scientific and technical information to support the claim that digitized signals sent as wave pulses representing zeros and ones can be used to encode and transmit information. Let's go back to the Moodle site and see what other resources we have. As we scroll down through the site, remember that you're going to try to plan your unit using the 5E: engage, explore, explain, elaborate, evaluate. You can also use your Harcourt Science textbook. There's a lesson, What Are Waves, that starts on page 648. There's some resource here, PDFs from the National Science Teachers Association, that gives you some content information as well as classroom activities. We have 2 Bill Nye videos for you. One is on waves, the second is communication. These could be very good engage, or they could be used for explain. There's a Discovery Education animation for wavelength. You're going to go to the Discovery Ed website and log in and look for this activity. We've got a couple things here from Bozeman Science. Bozeman Science is a website where a teacher, Mr. Paul Anderson, presents information for advanced placement students. These 2 video clips here are really good for teachers to help you understand a little bit more about waves, but could be absolutely used in a 6th grade classroom. I would suggest that you pause the videos as you work to explain the vocabulary and let students really come to understand the information in his video and graphics. We've got several different interactive animations for waves, a couple websites that are really good, some more activities, and then these PDFs down here, you can print these out. That has content information for your students. This would be used in your explain section of the unit. Scrolling down, we've got 2 MCAS questions. Would be great if you can start practicing these open response questions. The basic question is here, samples of student work. This icon for PhET, you click on this link, it will take you to a website with a simulation for waves. This one would be excellent in a computer lab to have the kids really look at the properties of waves. And if waves and information transfer technology is new, check out our content refreshers for teachers. These are some videos, very short, that you can watch, which will help give you some more of the content information you need to teach this unit.